This is the story of tantalum, element number 73. Tantalum is incredibly useful in many industries due to its large range of applications and rare properties, one of which Swedish chemist Anders Gustav Ekberg named it for. He named tantalum after Tantalus. In Greek mythology, Tantalus is a figure who was the first mortal to dine on Mount Olympus, the home of the gods. Because of this, he got a big head and tried to bring back the food of the gods to his fellow mortals and or tell them about what the gods had in store for them. The gods, however, did not really like this, and telling them that he would like to apologize, he invited them to his home in bad faith and decided to chop up his son and serve him as chicken to see if the gods were really omniscient. When the gods found out about this, he was killed and sent to the Greek underworld and punished by being forever starving and dying of thirst with amazing food and water all around him, and it moving away the second he got close to it. Because of this, when Ekberg discovered the metal in 1802, he named it tantalum because of its resistance to acids. Just like Tantalus could never quite reach the water and fruit, tantalum doesn't easily react with acids, making it seem elusive and unattainable in a chemical sense. It was confused with niobium until 1864 due to their similar properties and the fact they could be used mostly interchangeably. Tantalum's other features that make it so advantageous are that it is highly recyclable, resistant and non-reactive to human bodies, hardness in alloys, good ductility, high tensile strength, electrical conductivity, and its extremely high melting point, the fifth highest of any element with a melting point of 2,996 degrees Celsius. Due to these abnormal properties, tantalum possesses a large range of uses, including electronics and repurposing electronics, shielding NASA equipment from radiation, missiles and rockets, commercial and fighter planes, especially in engines or surrounding equipment, nuclear power plants, chemical handling and manufacturing, and medicine and surgery equipment or parts left in the human body indefinitely. Currently, scientists are searching for the radioactive decay state of the tantalum 180 isotope that has never previously been observed. Researchers are now conducting experiments that aim to measure this decay, which is expected to have a lifetime approximately 1 million times longer than the age of the universe. Other scientists with the US Department of Energy have discovered that adding a layer of magnesium improves the properties of tantalum for building the base of the new generation of quantum computers that are starting to be made. In terms of the future, the average abundance of tantalum in the Earth's crust is low, with about 0.7 parts per million. However, estimated global reserves of tantalum are large and more than sufficient for foreseeable future demand, with Brazil and Australia as the current main global producers, with some smaller mines in Africa. Tantalum might play an increasing role in the future as scientists discover more applications for it, allowing it to continue its rich history.